So I'm just going to give you the vocabulary and the steps and stuff, and then you can work. I'll give you a couple minutes to work on each section, and then you'll be able to go back and ask me questions. So the test is 9, 10 problems, something like that. You have to be able to do 8 plus to be able to get a 3. And to be able to get a 1, you need to be able to do at least 4 problems. So keep that in mind as you go through this, that you have to be able to do 2 different kinds of factoring to get a 1. So first thing we have to do, when we are doing the GCF, this is the very basic, and you're going to do this for all of them. GCF stands for? Look at you. I don't know why my pen is weird. Freaking... greatest common factor. Shh, hush. So you find out of all the coefficients, the numbers in front of the terms. And you're looking for the largest number. So you're going to use your blue card. Hey, turn around. Shh. And then to find the GCF for to find the GCF for the exponents for all the variable terms, we look for the smallest exponent. So what can I divide everything by? So then we write the GCF. Somebody messed with my colors. In front of some parentheses. I don't know why I just did that. And then you divide each term by the GCF. So when you're looking at this, for this first one, what's the GCF? What can I divide all those by? 12, 30, and 42 can all divide by 6. And then what's the smallest exponent? I've got 8, x8, x7, and x4. So I'm going to use x4. So then you write 6x4 on the outside. And here you would put whatever it was when you divided. So 12 divided by 6, 30 divided by 6, 42 divided by 6, and then you subtract your exponents, okay? When we have 4 terms, so this is how we start with anything. Doesn't matter how many terms. So the examples here are, the examples have 3, 2, and 3. I could have 4, I could have 6, it doesn't matter. Every time, the first thing you should look for is a GCF because it makes all the rest of it a simpler process. When I have 4 terms, and this only works when I have 4 terms, we can do for grouping. So the first thing we do, look for a GCF all the time. It just simplifies the process. Then we group the terms together. That's why it's called grouping. So I have the first 2 and the last 2. You might need to rearrange. Then we factor out the GCF from each side. Because by grouping it, I've said, okay, these 2 have something in common and these 2 have something in common. What can I factor out? And you're trying to get that second term for both of them to be the same. So when we look at number 4, notice that both of these can be divided. They have x's in them. And both of these can be divided by 5. I could change it. I could rearrange it so that I was doing these two and these two, because now I can divide both these by 2x and I can divide both these by 3, and I'll still get the same answers. So there's more than one way to do this, but usually it's already set up so that you can just break it in two groups and factor it. So here I can divide by x squared on both of those, and I can divide these both by 5. So I'm going to have x squared in a parenthesis plus 5 in a parenthesis, and when you're all done, one of them is x squared plus 5, and that other one is the common parenthesis. So if you can do both of those correctly, that's probably a 1. Now we have the AC method. As soon as you have 3 terms, we're going to try to use the AC method. I think on your paper, make a 6 here and a 4 here. I think they made a mistake when they were typing this up. So some of these are greatest common factor, and some of these are grouping. So this is what you're going to do. Make sure that you change this exponent and this exponent. Make sure I'm looking at my teacher copy here. Yep. Make sure that you change those copies so that, those two problems, so that you have a x to the 6th and x to the 4th. Otherwise, it will not give you the right answer. All right, so that's for you to practice. When you have questions, you come see me. So you're either going to take out the GCF or you're going to use grouping. On the back page, I made this small so I could fit it all on one page so you weren't freaking out by having so many copies. What's the first thing we always look for? Greatest common factor. Each time. I'll give you the steps for level 4 in a second for those of you that want to try it, but here at least always check for the GCF. Make sure that it's in standard form. That's descending order. That makes it easier to visualize. It puts the parts in the right places. To solve the X puzzle, so we're going to use the X puzzle. We need to find two numbers that multiply to be AC and add to be B. Then we split whatever the middle term is and use grouping to solve. So we'll do the first one just because this one is more in depth than the other ones. So it's in descending order, and so I'm going to label A, B, and C. So that I make my X puzzle. A times C is 3 times negative 21. That's negative 63. And B is negative 2. So the factors of 61, if I want it to be negative, it's plus 1, negative 63, minus 3, backwards. Positive 3 minus 21, and positive 7, negative 9. Did I miss any of the factors? No. So the one that works, that's going to add to give me 2. So then you rewrite this middle term as positive 7x minus 9x. So then I rewrite the whole thing, 3x squared plus 7x minus 9x minus 21. I can group this one and this one. I can divide by x, and I can divide by negative 3. So I have x times 3x plus 7 minus 3 times 3x plus 7. So then I have x minus 3, 3x plus 7. So we checked for no GCF, there weren't. Then we checked for standard form, yes. Then we found the two numbers that multiply to be AC and add to be B. We split the middle term. We use grouping to solve. So from here down is grouping. This is the part that's the AC method is up here. All right, a difference of squares. So the thing to remember, and it just kind of becomes a pattern that you recognize and then just go from there, but every time that I see a difference of squares, I just remember that I'm going to subtract 1 and add 1. It's the same two numbers. It's the square root of both sides. And you're going to add 1 and subtract 1. Remember, the difference means subtract. If it's an addition problem, I don't know why I'm writing that. If it's an addition problem, we can't do it this way. So first, we write the polynomial in descending order so that it's standard form. Always, always, always factor out a GCF. And then make sure that nothing else can be factored. So when we look at the first one, the first thing I want you to recognize is that this is a square. So then we go over here and look at and try to figure out if that's a square. That's on that list I gave you. That's the square root of 15, or that's 15 squared. So the answer, the square root of that is 15. So you take the square root of both sides, both terms, and I get x and 15, and then it's x minus 15, x plus 15. Even though this is not a square, it is an even number that I can divide by 2. So I can take the square root of this, and the square root of x to the 4th is x squared. And the square root of 625 is 25. So I have x squared minus 25, x squared plus 25. Now it says to make sure that nothing else can be factored. Shh. Can this be factored? That's a perfect square. x squared and 25 are perfect squares, so that one can go again. So then I have x minus 5, x plus 5 times x squared plus 25. That should all be in one row, but I ran out of room. So make sure that you can break it down all the way to the last one. Now when we look at number 5, it is the same thing. I need to see if I can take out a GCF, which I cannot. So then I need to try to figure out how to, if I can use the AC method. So I need to multiply to be negative 20 and add to be positive 1. So that's negative 4 and positive 5. So you rewrite this middle term, negative 4x plus 5x. So I have x to the 4th minus, sorry, those are squared terms, 4x squared plus 5x squared minus 20. I can divide this by x squared and this by 5. So I have x squared times x squared minus 4 plus 5 times x squared minus 4. Bring it back. So that my first finishing place looks like that. But this piece is a difference of squares. So then I have to go again. So then I have x squared plus 5. That's not a difference of squares. And then I have x minus 2, x plus 2. Any questions about what you need? Anything I missed as you were going through the note parts? I want you to work on the practices, on the practice questions, and then come ask me questions and I'll come around and check on you.